The first ever interstellar visitor to our solar system is wrapped in a layer of organic insulation, scientists have said. Oumuamua has enthralled astronomers and the public since it flew through the solar system in October. As the first alien rock to travel here from another star, it was immediately recognized as highly unusual, but as scientists learn more about the object, they are discovering how strange it actually is. Its strangeness has even led to suggestions it could be an alien artifact, rather than just an incredibly abnormal natural object. Very little is known about what Oumuamua is, where it came from, and what it is made up of. Scientists had relatively little time to study the object as it passed through our solar system, and they're continuing to analyze the data that was obtained. Before the rock arrived, scientists had expected that visitors of its kind would look like comets as they flew through the solar system. Such items would be made up of ice that would leave a visible behind them as they traveled past hot stars, they suggested. But when Oumuamua flew past, no such activity was detected, despite flying close to the Sun on its journey. Now scientists taking part in different studies have released detailed findings on what the rock looks like and what it might be made of. While it is probably an icy body as expected, it appears to be wrapped in an organic coat that shields the frozen water inside from being hit by the sun, according to the new research. In the end, this was a nice result because we've expected all along that the majority of objects that would visit our solar system would be icy in nature, said Alan Fitzsimmons from Queen's University Belfast and the lead author of one of two major new studies into Oumuamua. It has been a puzzle that this thing looked like a big lump of rock. Our study says that this object could well be icy in nature, but we didn't detect that ice due to the fact it's been baked by energetic radiation between the stars for hundreds of millions of years, or even billions of years. It is not certain that Oumuamua has any ice at all. The conclusion of Professor Fitzsimmons' work is only that it can't be ruled out. But that is because it is wrapped by its strange organic coat, and scientists can only see the very thinnest layer at the top of the object. The coat was examined by using spectroscopy, which looks at the light being reflected from its surface and splits it down into its wavelengths. By looking at those measurements, scientists can work out what the object might be composed of. What we didn't see is the signatures of the rocks you'd usually find on Earth, or you might find on the inner asteroid belt surrounding our Sun. Professor Fitzsimmons said. It appeared red, but when looked at through infrared light it became more grey in color. That was expected. It is what would normally come back from icy objects in our own solar system, but there did not actually appear to be any ice water coming off the surface. Normally, ice is expected to fall off such an object as it flies by the Sun, and the ice is warmed, forming a miniature comet. Looking at it, we realized it had been predicted that icier objects exposed to interstellar space should naturally form a thick crust around themselves, said Professor Fitzsimmons. When we crunched the numbers, we found that this crust should insulate the interior of the object so that if there were any ices inside it, it wouldn't change the form. Scientists had long expected that we are sometimes visited by such rocks, thrown from elsewhere in the universe into our solar system. We know that significant numbers of comets and asteroids were thrown out of our solar system when it was formed, and so can reasonably assume that the same thing happened in other planetary systems. But they are difficult to spot since they are so dark, and none had actually been seen until now, marking an unprecedented breakthrough. In some ways we had expected these things for some time, said Michelle Bannister, also from Queen's University Belfast and the author of another study of the strange rock. Our own solar system has ejected millions of very small rocky bodies, and so we should expect that others do the same. Both of the new studies attempted to understand how the rock looks and what exactly it might be made of. Professor Fitzsimmons used spectroscopy and thermal modeling to try to understand the rock's composition, while Dr. Bannister's research observed the color of Oumuamua and used that to try to discover how it looked. Studying the rock also gives a unique opportunity to understand how other stars formed and how objects might cope with the harsh environment of space, by giving us a direct look at something that has endured it. The work was destined to find something of interest either way, since the rock is such a strange visitor and is very old. It's traveled for millions of billions of years. It could be older than our solar system, said Dr. Bannister. The work to find what color it is, for instance, found that the rock appeared to be red. But the exact kind of red, which could indicate what it is made of, appears to vary, with some initial observations suggesting a dark color while others showed it being more neutral. Those neutral colors were largely in line with some of the objects we see in our own solar system. It's come from a very long way away, but it looks very familiar, said Dr. Bannister. It was the opposite of what I was expecting we might see. Dr. Bannister has been working on a project called the Outer Solar System Origins Survey. That work uses telescopes to measure the colors of objects in the distant reaches of our solar system, and has developed techniques to help understand what those faraway rocks might look like, difficult, when they are so dark and far away that little light comes back. So when Oumuamua flew past, Dr. Bannister and her colleagues looked to do the same thing for this rock, and see if we can put this object in context with this really well-characterized set of objects. They began observations soon after it was first detected. That was doubly important because the trajectory that the rock was coming towards us from meant that we did not actually see it until it had gone past the Earth. So there was a rapid effort to turn all the facilities that might help to look at it and learn as much as possible before it was too distant. Scientists hope they can spot the next object quicker, after waiting 19 years for this one. Oumuamua was first spotted on the 19th of October, by the Pan-STARRS project that uses a range of different technologies to observe the sky. Scientists realized very quickly that it was both an unprecedented visit from outside the solar system and that they would have very little time to get a look at it before it disappeared, meaning they rushed to learn as much about it as they could. It took a few days for everyone to be convinced that the orbit truly was from outside the solar system, said Dr. Bannister. With the next one, hopefully that'll happen more quickly. It's been 19 years, and you do see comets that have interesting trajectories that then turn out to be from our solar system, from the Oort cloud, 40,000,060,000 times as far from the Sun as we are. Sometimes comets coming from that can look like they're coming from outside the solar system, so there was a certain degree of caution. What we're hoping for is not to do anything different, said Professor Fitzsimmons. Astronomers around the world threw everything at it. But what we'd really like is more warning. More time means more data, and more ability to figure out what we want to learn. Spotting another object from outside our solar system will be just as interesting as the first one. Going from having seen one visitor to two means that we can start trying to understand how typical a strange Oumuamua is. What would be great would be to find another one of these objects where we can say, yes, this object came from this particular star, a particular region, said Professor Fitzsimmons. At the moment, the only limit we've got is an upper limit of about 10 billion years, because when our universe started, the materials weren't around to form a solid body like this. There's definitely going to be a lot more work to be done, says Dr. Bannister. The rock is still being watched as it leaves the solar system, and in useful ways, by tracking its trajectory as it leaves, we can learn more about the path it might have come in on. It's too far away now, it can just about be detected by the best telescopes we've got, said Professor Fitzsimmons. The important thing is for us to be ready for the next one. And it might take a few years for the next one to be detected, but the UK is already part of a project building the next generation survey telescope down in Chile. When that gets finished, we're hoping for one a year. Until then, researchers will keep looking through the detailed and extensive data that has been generated about Oumuamua. We might not know everything until well into next year, when more data becomes available. The object is very thin and very long, just what you'd design for long-distance space travel, and appears to be taking a strange trajectory. Those strange characteristics have led the Breakthrough Listen project, supported by Stephen Hawking, to point telescopes at Oumuamua and see if any radio transmissions can be heard. There are enough surprises about the rock already without it being an alien object, said Professor Fitzsimmons. And besides, strange though it is, Oumuamua does at least look like what you'd expect to have been created in the violent beginnings of a solar system like ours. If you've got a radio telescope, why not do that? He says when asked about the excitement around Oumuamua's potential alien owners. However, we expect these things to exist, because we expect such things to be flung out of all solar systems when they form planets. So we expect these things out there. And looking at this object, the first object that's been detected, it has appearances of these natural objects that we'd expect from another star. This looks exactly what we'd expect. Reuse content.